I'm Peter Norvig. This is Julia Wilkowski. We're going to talk to you about how to make sense of data coming from online classes. I think there's a great opportunity now, we all know, of so much more information being available, so many opportunities to take online classes. But if you're running one or you're trying to understand one, how can you tell what's working and what's not working? First thing you need is to understand the data is to be able to take a look at it. Last week we had a great talk at Google from Mikey D, one of our site reliability engineers who went to work on the healthcare.gov site and was part of the team that helped rescue that from not working to working. And he reported that the very first thing he did was say, we need to have a dashboard. We need to have big screen TVs in every room that says exactly what's up and what's not. It's not very sophisticated, right? So I could stand here and lecture you about complex statistics and machine learning algorithms for understanding data. And yes, there's a place for that. But the main part is just to have the data and start looking at it. And the great American philosopher Yogi Berra summed that up. You can observe a lot just by watching. So what can we look at? Well, here's the past and the future. So on the left is the report that you get from standard education, a college transcript. This has a bandwidth rate of about 10 bits per semester. On the right is a mobile device. This has a bandwidth rate of 192,000 bits per second. So that would be more. You also notice, if you've ever had to pay for college, that the one on the right is actually cheaper as well. So how can we take advantage of all the data that is now available compared to the paucity of data in the past to improve education continuously? That's the challenge. Google's always been a data-driven organization. So we're comfortable doing that. I see some of our friends from Coursera are here, and they were kind enough to lend us this dashboard, which is the simplest plot you can make, which is just the number of users that are on the site over time. And from this, you can see three components superimposed. One is that there's a startup. So not everybody gets going on time. It takes a couple days into the class before people start to get into it. Secondly, there's an exponential decay. Now, Coursera got to choose which class's timeline they wanted to publish. So this decay is much less steep than for most of the classes, which usually drop off a lot more of their students over time. And the third is these spikes, this Stegosaurus-looking pattern. Anybody know what those spikes are for? Due dates, exactly, right? So some people thought that they were weekends or something like that. If you've looked at weblogs, yeah, there's always a weekend pattern, but these are due dates. So we've proven that due dates are in fact important. Here's another dashboard that this was from one of the classes I taught, and this is just each of the assignments and the percentage of people who got it right. And you go through, and mostly they're doing pretty good. There's 80s, 90%, some even in the high 90s. And then there were two problems where they're doing really bad. And that doesn't mean the students are bad. That means that we screwed up. And yeah, I take a look at the problems. And it turns out one of them, I had said something kind of ambiguous in the wording, and that tripped people up. And the other one, the TA had written the wrong regular expression to grade the examples, and that screwed up. But we had this, and we were able to fix it quickly because we're monitoring it all the time. And here's another dashboard. This is a dashboard that a student would get from Google Classroom, which is one of the products we offer. But there would also be a similar dashboard for the teacher and for the administrators and so on. So you just want to be up to date and know what's going on. Now let's get into a little touch of the more sophisticated machine learning after we've driven in this point that you got to just pay attention to the data. So what this is a graph of states that students went in submitting programs for a programming assignment. And it starts off in the lower left-hand corner and start at state S, which is submitting an empty assignment, and then you build up from there. and the students followed these various paths. And each of the circles was made by clustering together similar programs, by having an algorithm that figures out the similarities between two different programs. And the size of the circle is how many of those programs there are. And the G1 and the G2 are two goals, so there's sort of two possible solutions to this assignment. It was a simple assignment, so there's really basically two solutions. And students converged along various paths to get to one of those two. And most of the students made it to one of those goals. But you also see a couple states that were with no paths going out of them, like the state 16 over on the left. So a small number of students got stuck in that state. And so this was an automatic clustering algorithm that gave us this kind of graph. And now you can use your non-automated analysis to go in there and say, hey, what's happening in state 16? Why are students messing up? Why are they getting stuck there? Why do some students take this path from 8 to 11 to goal 2, and some other students take this other path? It gives you something to start on to understand what's actually going on. And this is just one more example, a little bit more artistic looking from this same work. This is work by some students at Stanford University. Okay, let's have one more example. So let's say where we have another programming assignment and we describe the mathematics of what you're trying to do, and you write a mathematical equation like that. And when you write that, if you have beginning programmers, they often try to translate it literally. So if you're writing Python and you took that math and transliterated it, that's not going to be a valid Python program. Anybody know what the error message is going to be? So it's going to be type error, float object is not callable. So not a very useful error message for a beginner. The reason that happens is because X was a float number, and what's going on there, this is syntactically correct, and it looks like a function call where the thing on the right is the argument and the thing on the left is computed that should be something that computes to a function, but it computes to a number instead. So this is a terrible error message, unless you're an expert in the language. But compare that to what you sometimes get when you go to Google and you type in something and you make a spelling error. You get something like, did you mean? And then we give you a pretty good suggestion. And we do that not because we have a formal grammar of English, but because we have lots and lots of examples of people who came before who typed one thing, didn't like what they got, and then typed something else. Compilers don't have that corpus of past history. They just know what the grammar of the language is, and they know whatever tricks the compiler writer put in. But we can now instrument compilers to say, let's take this, take all these bad programs that students wrote, the mistakes that an expert would never think of, and have that as part of what the compiler knows. And we could do it for first-year students. We could do it for more experienced students. We could do it from students coming from one language to another language, and we could even do it for a particular problem, for this one assignment. We could say, take all the last submissions that students made and the errors that they made and build a compiler that's specialized for that. We have that capability if we can collect the data. Okay. Item response theory is an approach to understanding the relationship between the difficulty of problems and the capabilities of students. And here we have students clustered into bins, into histograms. So the better students are on the right, the worst students are on the left. And here's two problems. The blue problem was a pretty easy one. So the best students got 100%. The worst students are around 50%. The red problem is a hard one. So the best students are only 60% or so, and the worst students are at 20%. But these are typical curves for problems. But now we get a curve that looks like this. And this is an indication that something's wrong. So what's happening here? So the best students are doing better than the mediocre students, and they're getting 30 or 40%. But the bad students are doing better than the best students. That's an indication that something is wrong. We took this problem, went in and looked at it, and we found that there was A, an ambiguity in the wording of the problem, and B, if you made a math mistake, those two mistakes would cancel out and you would get it right. So the bad students were getting it right more than the good students. And you're only able to discover that by making this plot and doing this kind of analysis. Okay, so that gives you some hints of the types of things you can do with data. Now, Julia is going to tell you more specifically about what we've done with the classes that we've presented at Google.
Thanks, Peter. So as Peter mentioned, my name is Julia Wilkowski, and I'm one of the instructional designers at Google. And I've been involved in 6 of the MOOCs that we've launched to the general public. And I'm going to give you a little bit of an overview about the work that we've done, what we've learned from our courses, and some design implications for other people who are thinking about creating online courses and helping the ecosystem evolve. So I'm going to start out by asking, how many of you know what a MOOC is? Raise your hand. Great. I'm seeing about 90% of the audience raising their hand. But just for the other 10%, I'm going to define the acronym MOOC. It stands for a massive, open, online course. By massive, we mean these classes have had upwards of 150,000 registrants at a time. By open, we mean that they're available, most likely for free, to anyone with an internet connection. They're online, meaning that anyone, again, with an internet connection or access to the internet can access them. And by course, we imply some kind of a structure, a start date, an end date, some kind of an instructor or professor who's involved in the course, either as a figure in videos or able to answer questions throughout, and a sense of community where people together are going through the course within a similar time frame. Now, I should mention that Peter actually hates all of the words in this acronym. And I also don't believe that MOOCs are the future of education, or they're going to put universities out of business. And Google's role is we're trying to figure out what really works well in online education so that we can help move the ecosystem forward. So about 2 years ago, there have started to be more and more of these online classes from our friends at Coursera, Udacity, and edX. And some of us started to wonder, well, these courses seem like they're using a lot of the similar tools that Google has made available for free to the public. So we wondered if we could replicate what a lot of these other platforms were doing with Google tools. Thus, we created Power Searching with Google, which was a search course to teach the members of the general public how to use Google search tools more efficiently and more effectively. We had about 150,000 students register for this course. About 40,000 of them completed it. And along the way, we learned a lot. So here's a brief timeline. We launched this course in July of 2012. Several months later, we re-released the same course after we fixed a number of bugs. At the same time, we released the Course Builder open source code, which powered the Power Searching course. Since that release, almost 2 years ago, 94 partners have released their own courses using this code that we know of. There may have been other downloads and releases that we weren't aware of. And people are using this code in many different ways to launch their own MOOCs, as well as to implement a flipped classroom approach, where people are using the infrastructure that we provide with videos to assign videos before the class and have their students come together in class to have better discussions and solve problems together. We then tried another class called Advanced Power Searching. We launched a course for web developers on implementing web accessibility best practices. We launched Mapping with Google to teach people how to use Google Maps and Google Earth more efficiently and more effectively about 1 year ago. And most recently, we launched Making Sense of Online Data just a few months ago. So in all of these courses, I've been involved in some way, whether it's scripting videos, writing activities, writing test questions, figuring out how the community can help support each other, and analyzing a lot of the data that's coming back from these courses. So again, to figure out what works and what's not working in these online experiences. So 2 of our areas of research have centered around scaling evaluation mechanisms, and the other one is about why students register for a MOOC and what we can learn from that. So the Power Searching course, again, our first course, was a very traditional online course, even though we had a massive scale, where you watched a video, you did some activity questions, you watched another video, you answered some more questions, and at the end, you're presented with a multiple choice test to evaluate how well we felt that you had achieved those skills. But Advanced Power Searching was slightly different. We wanted to teach people how to solve complex research challenges using Google tools. And by complex, we mean that the problems had maybe more than one right answer, more than one right way to get the answer, or multiple steps that you had to achieve to get the answer. So we presented students with a number of challenges, which I'll show you an example of in the next slide, with supplementary videos and case studies that you could use if you were really stuck solving that problem. For evaluation, we asked students to submit case studies of how they had solved a search problem related to their own lives. Actually, we had them submit 2 of these, followed by a final challenge, which we graded via machine grading, or regular expressions. So here's an example. I know the text is hard to read, but let's say you were hiking and you saw this feather on the ground, and you didn't have a camera with you, so you whipped out your sketch pad and you drew a picture of it so that you could identify it once you were back in internet range. So this was one of the challenges we presented. What is this bird? And if you're really bored during the rest of this talk, you can try to figure this one out as we speak. So our question was, how could we effectively evaluate learners' qualitative work at scale? We'd already shown that we could effectively evaluate multiple choice questions and short answer questions, but we really wanted to evaluate these case studies because life is more like a case study than a multiple choice question. So we decided to evaluate or practice using self-evaluation methods. And we decided to go this route instead of the more traditional, and traditional in quotes because the MOOC space is not anything but traditional, but we decided to use self-evaluation metrics instead of peer evaluation for a couple of reasons. Some of the research that we've read has indicated that people learn more when they're evaluating their own work than evaluating someone else's work. You're also a little bit more motivated to evaluate your own work than someone else's. And again, some of the research has indicated that you have better metacognition, which is you're thinking about these skills and you're evaluating your own work even after you leave the class. So for example, we asked students to present a case study of how they solved a complex search problem. One of the questions we asked them to evaluate was how well they had evaluated the credibility of those websites. So this is because we want them, when they're doing a complex search challenge after the class, to think about the credibility of the websites that they're looking at. So here is our process. We had students submit their case studies. We gave them a couple of practice calibration exercises where we had graded them, where the course staff had graded them. They got some feedback about how well they were grading these practice exercises. Then they evaluated their own work. And at the end of the course, we scored a random sample of assignments, and we wanted to see how well the students' scores aligned with our course staff scores. And here's what we found. Now, ideally, all of the students' scores would line up 100% with the TA scores, and you'd see every single dot on that diagonal line. We didn't quite see that, but we did see over half of the assignments were within 1 point of each other, again, TAs versus student scores. And surprisingly, 73%, or nearly 3/4 of the assignments, received at least a B by the TAs. So this seemed like it was a promising start, but we knew we had a long way to go. Now, you may be wondering, well, what's to prevent someone from giving themselves 100% even when they submitted nothing or poor work or someone else's work? And we did see a little bit of this. In fact, 70% of the assignments gave themselves full credit. Not all of them merited that full credit score. And of those, 10% were blank, and another 9% were duplicate assignments. So again, this was promising, but we had some work to do. So how could we improve how students evaluated their own work? In our next course, Mapping with Google, we had students complete a final project, which was to create their own map using Maps Engine Lite to tell the story of some geographical data. Here's an example that compares apple and orange production in the Americas. Students were asked to come up with their own data set, or we gave them some provided data sets. They had to style the points in some way that told a story. So again, we had a very similar process where students submitted their work, they calibrated their work, they evaluated their own work, and after the course closed, we evaluated a random sample of those assignments. And we saw much better alignment in this class than the advanced power searching class. again, nearly 3/4 were within 2 points, and almost 100% received at least a B by the TAs. So what changed between the first class and the second class? Well, a couple of things. One, in the search class, we felt that our criteria that people were using to evaluate themselves were much more subjective than objective. So for example, how well did you evaluate the credibility of a website is much more difficult to evaluate consistently than how many points are on your map 1 through 5, for example. So having that clear rubric or checklist or criteria was, I think, one of the key factors that improved our results. Another key factor was this last one on our screen. We asked students how worthwhile was doing this project. And in the search class, just under half of them said, yes, this is a really worthwhile project. In the mapping, nearly 3/4 of them said, yes, this was a really worthwhile project. Now, the survey scores might have some self-selection bias, but I think there's something here, that if students find more value in the work that they've done, they're going to be much more likely to grade it on a more accurate level. So what does this mean for people who are creating online courses and online course platforms? We feel that self-evaluation is an effective evaluation mechanism for some low-stakes environment. Now, of course, you're not going to get a job at Google if you pass our class, although some students did think that. And I mentioned this in a research presentation that I gave on this. And I made the offhand comment that, well, I'm not sure I would want my surgeon going through a self-evaluation process. And one of the people in the room said that he'd actually had worked with surgeons and was practicing self-evaluation with them. So I don't know, maybe it does have merit in high-stakes environments as well. We found that it's really important to test our rubrics or grading checklists in advance, because I think we would have uncovered some of those subjective versus objective measures. Also, we think that it's really important to teach students how to evaluate their own work. And although we did it a little bit, I think there's a lot of room for improvement if we really want to give the students those metacognitive skills. So another area of our research has focused on how well students achieve the goals that they set out to achieve when they register for a MOOC. So first question, many of you knew what a MOOC was. How many of you have registered for a massive open online course? All right, I'm seeing about 80% of the hands. And how many of you completed that course? All right, I'm seeing maybe 20%, which actually is what we've been seeing as well. And if you've read any press about MOOCs, you'll see people saying, MOOCs only have a 10% completion rate. That's really dismal. So we wanted to unpack what this really meant. So in the Mapping with Google course, we had 40,000 registrants and about 20,000 active students from all around the world. And one of our first questions was, well, why do people register for MOOCs? There are lots of different reasons. So our research has differed from other people's research in that we're combining students' intent. We're actually asking them, why are they coming to a MOOC? And we're doing the analysis to measure how well they are meeting those goals. So at the beginning of the course, when they registered, we asked them up front, why are you here? And was it to earn a certificate in maps? Was it to earn a certificate in Earth? Was it to earn a combined certificate in both? Was it to learn about 1 or 2 new aspects of Google Maps? Was it to learn about 1 or 2 new aspects of Google Earth? Or were they just dropping in to see what this online course was all about? So not unlike the folks in this room, we found that just over half of the people actually intended to complete the course, and almost half had no intention whatsoever of completing the course. Now, if you stop and think about this from an educator's perspective, it's kind of shocking, right? As an educator, we feel like everyone wants to come and learn everything that we know and that we're going to offer them, and they have to go through everything in a linear way, right? Wrong. This data clearly shows that half of people had no intention of reaching the endpoint, or that they were redefining what their endpoint should be, which I think has huge implications in how we design our online courses. So we repeated this experiment in the web accessibility class. We found something very similar. Just over half of people intended to complete the course. So our next question was, okay, well, people have lots of varied goals. How well are they achieving those goals? So here was our process. Again, students, when they registered, selected the goal. They interacted with the course for a 2.5-week period. When the course closed, we extracted the course data as JSON files, and then we ran some R scripts to analyze their behavior. And here's what we found. If their goal was to learn new things or a specific maps feature, we found that nearly 2/3 of them actually achieved that goal. And the way that we inferred it was we said, okay, if they want to learn a specific maps feature, we then took the maps lessons in the course, and we saw, did they watch at least 90% of one of the maps videos? Did they complete one of the maps activities? Or did they read the maps text lesson? And if any of those criteria were met, then we counted them as achieving that goal. Even among folks who wanted to earn a certificate, which was a much more rigorous process, we had between 13 and 25% of people achieving those goals, which are much more representative of true life than if you hear the statistic, only 10% of people really complete MOOCs. So we found similar things in the Intro to Web Accessibility course. As a whole, in the mapping course, we had 42% of people meeting their goals. Web accessibility, about half. And again, what does this mean for members of people who are designing courses or creating courses or working on MOOC platforms? We feel that it's important to make content available up front, instead of the traditional metered way where the professor says, okay, week 1, this is what you're going to learn. And if you want to go ahead, you can't, because I'm not releasing the next set of content until week 2. And if you want to go ahead, you can't, because we're going to give you the next set of content the week after. So what if we could offer all of the course content at the beginning and enable and encourage people to search for the pieces that are relevant and interesting to them? What if, when we send out course emails to students, we could link to specific lessons that are based on their interests and their backgrounds? So for example, you said you wanted to learn how to navigate from point A to point B in maps. Let's give you a targeted link in that email that says, hey, you registered, you said you wanted to do this. Here's how you get there. We're experimenting with 2 other elements of the design, which is allowing students to create their own playlists, given a list of all of the course content. So what if we gave them a list of all of the videos, all the activities, all of the lessons, and all of the final projects, and allowed students to pick and choose to create their own customized course? Or if we did enough analysis, we could offer predicted learning paths that says, okay, the students with this background and this goal tended to go through the class in this way. Then we could offer the next set of students those learning paths. So we're going to keep experimenting with many of these elements, and we're helping the Course Builder platform evolve. And we're hoping that all of the other MOOC platforms will evolve so that in 5 years, MOOCs look completely different than they do today.
Okay. So I hope we've been able to tell you something about how we look at courses, how we look at the data we collect, and where we think it's all going. And we've got some time so we can throw it open for questions.
If you have a question, please come to one of the microphones. There's one in each of these aisles so that everyone can hear you.
How much analysis do you do of the online forum posts of students, and have you gained any insight from those?
That's a great question. And so the question was about our online forum posts. And the forum is a critical way for students to ask questions and get questions answered, either by course staff or by other students. And we actually haven't done a lot of sophisticated analysis on the forum posts, 1, because it's difficult, and 2, because we have to delete all of the forum posts 60 days after the course closed to comply with our privacy regulations. So unfortunately, we haven't done a lot of that analysis yet, although Google is funding some other researchers in cognitive linguistics to do some of that research. So maybe we can report on that next time.
And I think it certainly is important to monitor the forums and get a feeling for what's going on. You can learn something just by looking at them without doing the sophisticated analysis. It also is possible to do at least a sentiment analysis, right? So if you're looking for one bit, is this positive or negative? There are classifiers that will do that pretty well. But there still are a lot of privacy issues involved in what exactly what information can you keep, how much can you tie the identity in the forum to the identity of the student, can you tie that to their identity someplace else? And I think the field as a whole has to come to grips with these privacy issues so we can share and learn what we want without violating privacy.
A question over here.
Yeah, so what do you think about the distinction between an online course and, I guess, an online reference? I work at Udacity, and a tension we're struggling with all the time is, you want lots of students, of course, that's a good thing, but you also, we're a company full of educators who want to do really well for these students. We want to give them what they need, and sometimes what students think they want and what we as educators and experts in the field believe they need are kind of at odds. And so this modularity it's hard to incorporate modularity or ultra-modularity in that sort of way of thinking.
Yeah. I think there's a lot to say about that, and I think the course versus reference shows up in two places. One is for the schedule. Now, I showed you that graph with the spikes, and that says if you have a course with the schedule, boy, that really helps a lot. That motivates students to get stuff done. They know the deadline's coming up. They know if they go into the forum, everybody's talking about it at the same time. And so having a course with a schedule is useful that way. On the other hand, a lot of people drop out because they can't meet the schedule and they want to work on their own time or they want to go in their own direction. I'd like to have some kind of a compromise. I talk about what I call the bus model, where you get on the bus, there's a schedule, the scheduled stops along the way, and you work towards those. But if you want, you can get off the bus and wait for the next one. You may not be able to say, all right, I want to sign up, I want to continue tomorrow. Maybe you have to wait a week, but at least you don't have to wait a whole semester. So I think we want to work that out. And then the other part is, what is the content that you want to take? Should the student be allowed to pick and choose? I think we need some mixed initiative where the instructor knows something about how to put together a sequence, but the students also have their own particular needs, and we have to figure out a way to serve both of those. Did you want to add to that, Julie?
Okay.
Yeah. Hi, Peter. At the top of the presentation, you mentioned analytic dashboards, and I was just wondering if you'd been using Google Analytics as a tool to give a course overview and segmentation breakdown, that sort of thing.
Yeah. A lot of people have been using the Google Analytics, so this is a tool that you can track where people go through a site from one URL to the next. Depending on how your course is set up, that can be easy to difficult, right? So Google Analytics is designed to track URLs. You can set it up if you work at it to track all sorts of AJAX events. So you can get very fine, detailed students who were on this question and then they answered C on this quiz and then they went someplace else, or you can have it more not as fine-grained if you don't want to put in the work. So people have been doing that. You get some good reports just by looking at the raw Google Analytics. People sometimes feel like that's not quite enough, that it's, it was designed for like shopping websites and so on, and if you really want to get everything out of the course, sometimes you have to take the data out of the Google Analytics and do some separate processing on it.
But there is a course from the Google Analytics team about how to use Google Analytics more effectively, and they set up these amazing dashboards. They didn't look at any of the course builder dashboards. They just built everything in Google Analytics and had some really interesting findings as well.
Hi, my name is Daniel. I would like to know if you have looked at technical parameters, or if you're aware of technical parameters that can predict dropout rates, or how to lower them, either what kind of video formats are used, or I myself ran into a problem with one of the courses. The volume wasn't high enough, and I cranked it up all the way. I couldn't use it on my phone, so I just couldn't understand the guy, so eventually I gave up. So is that something that has been studied?
Yeah, I don't know how much. I mean, I think there's always a lot of factors. You can go into the forum and see what people are complaining about. It's sometimes hard to get the feedback, right? Because especially the people who drop out, you don't hear from them again. And you can send them a survey or something, they tend not to answer those. So it's sometimes hard to understand why they do that. As Julia said, and sometimes they got everything they wanted out of the class. So dropping out wasn't a negative for them. It was what they intended to do in the first place. I think look at all the factors, measure things, see what people are asking about in the forum, try to do as much of post-analysis as you can. If you can get people to answer surveys, that's really useful. And use all the tools you can.
And we did send out some surveys to people who didn't complete some of our early courses. And the #1 reason that people said that they didn't finish the course was that they didn't have enough time. And it's easy to say, I don't have enough time for something. But I think what that really means is that they didn't see the value in making that extra time for that course at that time, or they had some other urgent need come up. But it's easy to say there's not enough time.
But my question was more from the other way around. Did you look at, I don't know if it's Flash or if it's if people who use a certain operating system have higher or lower dropout rates? I don't know, Android 4 versus Android 2. I don't know, just some technical stuff.
We haven't looked at that data.
Yeah.
Okay. Thanks.
Hi, I'm also Daniel. And I got quite intrigued by the idea of self-selected learning paths because I've been trying something like this since 1999. I've been doing lots of online courses, and I found out that the learning path, it's like one of these sort of untouchable cornerstones, like both for the designers of the courses, like they were able to compromise on anything, but the learning path, A, B, C, D, this is mine, I will never let it go. And for the students, when they would go into the course, which was like just the pieces and let me find my path, they would feel kind of like confused. So I'm really interested if you have some more data on it, some more experience, like what is the reception of the students, what is the reception of the designers?
Yes, so I can talk about some experiments that we've run in the Making Sense of Data course. And this is actually interesting because in previous courses, we'd seen that people who do activities actually have a higher completion rate than people who just watch the videos or people who don't engage in the content in some way. So in this course, we decided, let's put the activities front and center. Let's encourage them to do the activities, and then if they're stuck, they can go look at the other content. And when we did some user testing, we actually found that they hated this model. People just want to sit and they want to absorb videos, or that's what they say at least. But our data shows that this isn't how people really learn best. So I think when you're setting up a learning path or encouraging people to set up their own learning paths, there needs to be some kind of a scaffolding where you give them some hints about what they could choose or what people like them have chosen in the past, or some kind of a map, or maybe there's 5 different options. I think if you just put it out there and say, just go create your own course, some really highly motivated people who are already succeeding in MOOCs will do really well and will love it. But for the vast majority of the population, I think they will be hesitant and not really know where to begin.
How about the training designers, the instructors, how they would welcome this model?
Personally, I love it as a training, instructional designer, because I want people to get out of the course what they want to get out of the course, and that it's tailored to them, because I think that will increase the motivation to complete the course or meet their own goals. Yeah.
I know for me, in teaching the AI class with Sebastian, we really felt like it was flipped, and we had read about what Daphne Kohler had done in the flipped classroom, but we really flipped our whole way of thinking about instruction by saying, rather than thinking, what is it that we have to say to explain a topic, we instead thought, what is it that we want the students to be able to do? So we first said, here's a skill we want the students to have. We want them to be able to solve this type of problem. Then we had to translate that into, well, how can we have them do that problem online? Where there's some limitations and grading it's hard and so on. And then we would come up with that. And then we'd design that exercise. And only then would we say, now do we have to open our mouths and say something? Right? And we have to say, now we have to introduce this problem. We have to give them some background. We have to tell them something. But if it turned out we could introduce the problem without saying anything, then we would just go ahead and do that.
Hi, I'm curious about if you've done any work on different levels of students, for example, early child education or high school students or college students versus adult education, and if there are differences in the kind of recommendations you would give for designing an online class in that case.
Great question. In all of our courses, we have seen similar trends to what the broader MOOC community has found, which is that the most likely population to take MOOCs are well-educated, English-speaking Americans who have heard between 35 and 45. So although the promise of MOOCs is that anyone, anywhere can take these classes and become enlightened, we haven't actually seen that realized yet. So unfortunately, we've had a very narrow population taking our classes so far. So we haven't done that kind of analysis of what's better for this population versus that population.
I think that's right, although the way I think about it is, you know, when you have such a big audience, you've got 100,000 people or something, there's multiple ways to look at it. And if you look at it by majority rules, then yes, the demographic that Julia described, that's the dominant demographic. They're the early adopters. So the people that are lining up to buy the latest tech toy on the day that it's announced, those are the same ones that are lining up to take these online classes. On the other hand, though the tens of thousands of people are in that demographic, there are people in other demographics that are spread out. There's the high school student, there's the Asperger's student who didn't fit in a traditional school. There's the kid in the developing world who otherwise wouldn't have had a chance. And small numbers of these are able to succeed. They're not the majority, but it's part of it. And we like to think about those. I think these people are succeeding mostly on their own, not because of something that we did, right? So we gave them the opportunity, but they had to be exceptional in order to succeed with that opportunity.
Hi, I had a question on the differences in platforms. I think not too long ago, Google said that they would be contributing to the edX platform. So I was wondering if you could speak to the differences in the analytic tools between Course Builder, edX, and possibly even MOOC.org.
Yeah, so MOOC.org is still a work in progress. So that's a joint effort between edX and Google, where it's going to be sort of the intent is that that will be the long tail, that edX is primarily focused on the partner schools that are part of edX, and MOOC.org will be for all the other schools. And we're working to support that, but it's got a ways to go yet. For edX, we work closely with them. We do stuff for them. They do stuff with us. We've worked towards interoperability. So, we contributed various stuff like easy Google login to them, and being able to take material out of our Course Builder platform and put it into the edX platform and vice versa. We're making it all run back and forth. We'd like to get to the point where the platforms are merged completely, but so far it's at the level of interoperability rather than merging.
Is there any time frame for retirement of Course Builder, or is it just?
We don't have a time frame yet. It's just there's some technical issues of basically the difference between Google App Engine and Amazon Cloud, and you'd think that stuff would just port automatically, but it doesn't. There's real work involved, and it'll take time to work that out.
Thanks very much.
I work for a brick and mortar university, and will luckily and fortunately be retiring in the next 10 years. I see a lot of these young faces in the classroom who probably are either pursuing or already have a traditional college degree. Do you see their children as even pursuing a traditional college degree, or do you think that the model is going to completely change over perhaps the next generation? That's more of a philosophical question than a logistical question, but it's really one of those things that I think about sometimes, that I really think everything's shifting, and whether 128 credits equals a degree that will be conferred on a sheet of paper from a university. I don't know if that's going to be in existence 30 years from now. So just kind of a directional, how do you think this is going to go?
I'm the wrong one to predict. I remember 20 years ago, my daughter was born, and at the time there was this sort of financial instrument you could buy that was a hedge against increasing cost of college. And I said, no way am I buying that, because in 20 years, everything will be online. So I was wrong, but maybe only by one generation. But I think what's more important than what leads up to your college degree is what's after that. And I think that, you know, this notion that you go someplace for 4 years and then you get a certificate and now you don't have to learn anything again, that's clearly isn't going to work. That we're going to have continuing education. You know, you're going to be educated in one field, start to have a career in that, and then that career is going to be automated away and you have to retrain in some other field. And that's going to be more common than it is now. So we'll see continuing education, whether it will be associated with traditional colleges or associated with these online institutions. It'll be some mix, and I can't predict what it will be.
And it looks like we are actually out of time. So thank you all for coming today.